Okay, let's go to the questions. The first question was asking about on how to find the reference angle, especially on the question of grade 11. This is going to be really a mathematician. He or she is interested in practical things. So we had sine 18x equals to minus 3 over 5. So we said we are done with that minus because we have identified the quadrant. That is now step 1. That was sine is negative in the third and the fourth quadrant. So we are fine with that. So what we need to do is to find the reference angle. To find the reference angle of that, let me switch my calculator on. We press shift or the second function. We are working with sine, so that will be the arc sine. That function on the floor there, when we go to shift, we'll be pressing that function which is called the arc sine. The Casio is so nice to open the bracket for me, and then it has got the fraction as well. But if you don't have the fraction, no problem. You can just say 3 divided by 5 directly. So I'll say 3 divided by 5 and move the cursor to the right, close the bracket, and I'm getting 36,869. And I think I decided to round it off to do 2 decimal places as 36,87. Now, the very interesting question, I think this question came before I finish off here, which is very crucial, was how do I know whether the graph is shifting to the left or to the right? Now, suppose you are having the graph of y is equal to sine into x plus 30 degrees. Now, we are saying, when will this bracket be 0? Why are we referring to 0? We are actually tracing this point here. This point. What will happen to this point if there are some changes? Now we draw x is equals, y is equal to sine of x plus 30. We ask ourselves a question, when will this bracket be 0? So when will x plus 30 degrees be equal to 0? Is when x, if we subtract both sides, minus, we subtract 30 on both sides, we'll end up having the right hand side as x is equal to minus 30. It means our mother function, for every point that we are having there on the graph of y is equal to sine x, every point must shift to the left. Why to the left? Because of this negative sign here. Then we shift every point to the left. Suppose we are having y equal to cosine of x minus 60 degrees. We want to draw that graph. When we draw that graph, we look at our mother function, the graph of cosine. We are actually tracing this point, 0 degrees is to 1. What will happen to that point? And if we work with that point, we'll say, when will this bracket be 0? So x, when will x minus 60 degrees be 0? It means when x, if we add 60 degrees on both sides, x must be equal to 60 degrees, and this 60 degrees is positive. It means every point of the mother function will shift by 60 degrees to the right. This point will shift there, this point will shift there, this point will shift there, and so on and so on and so on. That's how we know where does the graph shift to, whether to the left or to the right. Now, and this question has been asked before, and I'm trying to find the question. I cannot. I'm trying to find the answer. The answer for this will be, in this case, of which is one of the problems that we haven't done, they have said calculate the x coordinates of P and Q. As I've indicated, we are only going to get this, the two solutions for this problem P and Q. But if we've got lot of solutions that we've got to find out, in the case of that grade 11 problem, we had 4 solutions. If we've got to get more than 2 solutions, we've got to give the general solutions. Or if the 2 graphs are cutting each other for more than 2 times, we've got to give the general solution. The general solution is making things easier to calculate the points of intersection, or where the 2 graphs are intersecting each other. I hope you have enjoyed this session. Thank you very much. Up until we meet next time. There is a question from Rampine, which is very much interesting. She is asking about the effect of, say for instance, we've got y equal to sine 2x. The effect of 2 next to x, will it change the shape of the graph or not? Yes, it will. Look at our graph of sine, for instance. We have got y equal to sine x, and we are able to follow this pattern: 0, the value of y as 0, 1, 0, negative 1, 0, 1, 0, negative 1. So in order for us to draw the graph of y is equal to sine 2x, we would like to have the same pattern of saying 0, 1, 0, negative 1, 0, 1, 0, negative 1. Now, in order for us to have that pattern, in the original graph, we are having multiples of 0, 90, 180, 270, 360. In this case, we'll have 0 degrees there, but the next multiple that we must have, that will give us 90 degrees, must be 45 degrees. The next one must be 90 degrees. So this is changing the scale of the mother function. The period of the graph is going to come very quick. That will be 135 degrees. That will be 180 degrees. That will be 225 degrees. I'll not finish the whole thing. But now, as you can see, we must say 0, and then we say 1, 0, negative 1, 0, 1, and we try to join those points. As you can see, the period for that graph is between 0 degrees and 180 degrees. That has actually affected the period of our mother function, because our mother function had a period. I'm going up above the x-axis. When will I again go up above the x-axis? There I go, there I go, there I go. Then I'm starting to make the same thing here. So the period, the original period of our mother function of sine is 360 degrees. But this one, the new baby, the newborn, sine 2x, will be equal. So I'm going up above this x-axis. When will I again go above the x-axis? I'm going to stop here. Otherwise, I'm going to do the same thing. So that period of y is equal to sine 2x is 180 degrees. And indeed, this 2 has changed the period of the mother function and make it to be 180 degrees. Thank you. A very nice question, Rampine.